In the last section, we looked at natural pollutants. In this section, we're going to look at other things that pollute. So these would be the anthropogenic causes of pollution more. Right. So we're going to start with smog, which is, of course, smoke and fog combined. If you think about industrial applications, you have water, sulfur, and soot released. It really started appearing with the Industrial Revolution in the 1800s, and really is a byproduct of coal burning processes. It's particularly visible in industrial centers and near electrical plants because they do rely on coal so much more than other places. You can have photochemical emissions, so that's a NOx, a nitrous oxide, with a volatile organic compound, a VOx, and sunlight. These appeared after World War II, which replaced industrial smog with personal automobile emissions. Because you're burning gas and diesel, and those combustion products result in photochemical smog. These are visible in major cities with large automobile use, like LA. Smog accumulates during the morning and often clears overnight. So here is a picture of DC early in the morning. This is the same picture later in the afternoon. Natural terrain can exacerbate smog. So, for example, if you're surrounded by mountains, the air gets trapped in the hollow. Mexico City is a very good example of this happening. So this is Mexico City when there's a wind. This is when there isn't. Temperature aversions can also exacerbate, make it worse. Normally, air temperature decreases as a function of altitude. As warm air rises, so do pollutants. However, if you have an inversion, you get warmer air sitting on top of cooler air. This often occurs at night. And because of that, you don't get the flow of air upward, so the pollutants stay close to the surface and therefore don't clear out at night. Besides looking ugly, what are the effects of smog? Well, it can cause headaches, nausea, eye and throat irritation, or respiratory illness in humans. You can damage forests and other plant life. It can also lead to corrosion of metal. Let's look specifically at Mexico City. Most days it exceeds safe ozone limits. Mexico City has about 4 million vehicles and 60,000 industries, and as we mentioned before, it's in a hollow. Therefore, unless you have a wind, it doesn't clear out. The result of this is that 40% of children in Mexico City have a chronic respiratory illness. So what are the sources? We've discussed them a little bit. Combustion. There's an oxidation reaction that occurs when you burn an organic compound. So, for example, for burning methane, methane is CH4. You combine it with 2 oxygen molecules, and you get out carbon dioxide and 2 water molecules. There's wind transport, that's your dust storms. There's also evaporation. Volatile substances like paints or gas, when they evaporate, that results in a type of air pollution. So primary pollutants are derived directly from burning fuels or wastes. They include particulates, hydrocarbons, carbon monoxide, nitrogen oxides, sulfur dioxides, and lead. There's also the possibility of getting your secondary pollutants when you expose the primary pollutants to sunlight. So as we just said, secondary pollutants come when an interaction occurs between a primary pollutant and sunlight. They include ozone, or PANs, which are I can't even pronounce it, but it's a big long word that I hope you can see that begins with P there. And they're formed from your volatile organic compounds or your nitrous oxides, your NOxes. You can also get sulfuric and nitric acids as secondary pollutants. Those, of course, lead to acid rain when they're precipitated outward. Here are a bunch of pie charts which show different the sources of different types of pollutants. So the majority of ground level ozone is due to automobile emissions. The second largest source is gasoline powered lawn equipment. But we can look at, for example, sulfur dioxide comes from primarily fuel combustion. Nitrogen oxides are transportation followed by fuel combustion. So fuel combustion that is not transportation would be like a coal-burning power plant. Your VOXs, your volatile organic compounds, are almost equally created by transportation and industry. Particulate matter. It's the rare one that is a combination of everything else, if you will. It's dust, it's fire, it's anything that isn't transportation related, an industrial process, or fuel combustion. And carbon monoxide is almost all from the transportation industry. If we look at vehicles, so the primary pollutants are the volatile organic compounds and your NOxes, your nitrogen oxides. If you look at the nitrogen oxides, they come in, it interacts with sunlight, so you go from having NO2 to just NO, plus a free O. That free O can combine with oxygen gas to form ozone. The other thing that can happen is you take the nitric oxide, put it with oxygen gas, and get out some more NO2. If you combine nitrogen oxides with VOXs, again, you start with NO2, put some sunlight in, you get NO out. Combine it with O and you can get O3. Combine it with O and some VOXs and you can get things like aldehydes and ketones out, or many, many other compounds. And all of these are highly reactive compounds that damage plants and animals.